So previously we have been discussing about Python. So as I told you, that approach towards learning anything is you basically should do it. You should do a project or some stuff like that, and then you should get introduced to the concepts. So as you now know the basics of Python, let's suppose you know what a language is, what a high level language is. So now we'll move on to that experiential learning part where we'll do stuff and then we'll get to learn the things. So in that, what we'll do is we'll make a small project. So which I'll name as a personal finance manager or something. So this is what we'll be focusing on. Personal finance manager. Everybody who is here who hasn't done any software development, please focus more so that you get to know the whole pipeline, how the things are being done. The first thing is we have to identify a problem. So here if you see that I told you that we have to make a personal finance manager. Okay, what should be our objective? The objective can be, we can have a set of a bunch of objectives. So let's define our objectives first. What our objectives are. So in here I'll share a document about this. Okay, particularly focused on the undergrad people. So please add the more features that you want. I think this will be a good exposure to the people who haven't developed an app or who haven't done probably any work in the industry. So this is how we start. So first other thing is we'll identify a problem. So this is our problem. We want to make a personal finance manager. So what is a personal finance manager? Let's define that first. So we'll introduce all the concepts using that. So let's suppose you are having certain income or you are getting a pocket money from your parents, and from them then you want to track your expenses. Well, let's suppose you spend something on food, you spend something on your education, okay, and maybe you have some other sources of income. Okay, there are a lot of parameters that you have, and you want to track all of these things to get some sort of sense where is your money going and what is your investment pattern, what is your spending pattern, and you want to find that. So that is the problem at our hand. And many of the people after UPI has emerged into India, and people are basically overspending the money because now they don't have physical money, they just scan the QR codes and just buy things. So it's better we track our spending. So that is the problem that we have in hand. So we'll make a personal finance manager in which we'll track how much amount is going to different categories and how much income is, what should I do about that, and probably we'll do some analysis of the data also. So that is the problem. So now what are the objectives that we have? So first thing is we should input our income and categorize in different expenses. Okay, and then we'll track these expenses over time, and maybe we'll also load that into like files, or maybe store that into files. Okay, and then we'll analyze the spending pattern. I'll just write high level things that whatever comes to my mind. So that's why I'll create a document about these, and then what you guys have to do is if you feel that we can add more features to it, so you guys just write in the documents that these are features that we require in this. Okay, I'll share a document after this session, and where you will just write the features. These are the features that we want. And for the initial part will be we'll just make with a command line sort of thing. We'll just have it running on the command line. After that, we'll convert into graphical user interface also. So what is the objective? The first objective will be to input the incomes. Maybe people will have different streams of income, so they'll input their income, and maybe expenses also, input and expenses. And the second part is that we'll have to track the expenses. So we'll track the expenses. Okay, track the expenses over the time. And the third thing is we'll probably save and load this financial data. We'll store it into some files. We'll load this data into files. Probably we'll interact with some what's called as file management. So here we'll load and save. Load and save the data. Okay, then we'll analyze the spending pattern. Okay, and we'll keep on adding the features. So initially what we'll do is we'll just make a prompt based thing. We won't add any graphical things. After a while, once we are done with that, we'll revamp the whole thing and we'll create a graphical user interface for this. And all in all, you'll learn how to develop a whole pipeline, and you'll also get to learn different concepts of Python. Okay, because why have I done this from the third session? Because in the initial 2 sessions I had to set the context for these things. Why is programming needed? Now everything that we'll learn is basically for this project. Okay, so what is your work now? So you have to add features in the document. Add features in the document. That's your job now. I'll share a document. I'll add these are the features I just that came on top of my mind. After a while, you guys can add features. We also want these features, and you can make it a full-fledged application. Probably you can launch this application after that. Okay, so all the concepts that now I'll introduce will be somehow surrounding around these around this small probably a project. Okay, this will be of a great benefit to the people who are doing the coding for the first time. So please give your best in that, and I'll write some code in the class. You'll have to revamp the code once you go and have all these files with you. Okay, at the end, you guys have to sort of refactor the code and take the whole code and integrate it somehow in only one file while you can run all of these things. I hope that you got the gist of what I'm going to teach. Any questions regarding this? Okay, the first thing that I showed you is that you have to take an input and you have to print something on the screen. So okay, so there are functions for that. So Python has inbuilt functions, and we'll go into the details of what functions are. So first thing is we'll learn how to basically print something on the screen or take input. So we'll see how to print or take input. That we'll see in the coding environment. Let's go to the coding and let me just set up this. So if you can see my screen, so I'll just move on to this coding window. So here if you see, this is the terminal that I said. So this is my shell. Okay, this over here. So what I can write is I can say, let's suppose we'll write code and I'll name a file. This is input output .py. So .py is the extension by which when I run this file, so the compiler or interpreter, so here we have interpreter of Python, it recognizes it as a Python file. So I'll just name it with this, and you can see that on the left hand side a coding window popped up. This is just an editor where I can edit the files. Okay, now let's suppose if I write print something. I hope that I showed you this in the previous session. Print hello world. So I'll just save this file. So I saved this file and I'll come back to this terminal while I'll run the file. So how to run this file is you can just type Python 3. Python 3 is the Python version that I'm running. So then I'll just input the name of the file. So this is input output.py. So if I run this, you can see the hello world appeared over here. I hope that it's visible for everyone. Just give me a confirmation that you guys are following. Okay. So as you can see that, so here I also showed you in the previous session that we can have interactive Python also. So by interactive Python, you can just test some functionalities, or maybe it helps in debugging the code, and maybe if you're experimenting something, you can just type Python 3 on this. So you can type on Python 3, enter, and you can see this information over here, Python 3.1.2 packaged by Anaconda. So you can just test these things. So print, let's suppose hello world, something like this, and you can do it on the fly. That's what this is for. This interactive version is for. I'll just exit this interactive version and I'll probably code on the left hand side on the text editor. Okay, I hope everybody is clear with this so far. Now this is how I print something on the screen. So if you see, I have written print hello on this. So basically what this print is a function. We'll have a detailed discussion on what functions are, but here I want you to see these things. The first thing is print, and then we have something written inside it. So we have something written hello or world. So this print over here. So if you see, this is a function. Okay, what is called as a function. Okay, and then whatever text is written inside here, so they are called as arguments. Okay, so what's our job? The first job is, let's suppose we want to now take the input, and probably when you open an app, it greets you. So that's what we want to do. We want to take input name as an input, and then we want to greet that person. Okay, let's do that. So now we know that instead of hello world, I can say hello some name. Let's suppose we have here Ejaz, so I can say hello Ejaz. Now I have hard coded this name. So if I run this file again, so Python input output.py, if I run it, so you can see that it shows hello Ejaz. But what I want is, I want this name to be dynamic. It should not be hard coded. This is called as hard coding. If you have something which you hard code and you cannot change it. Now I want to take the input. So there is a function called as input. In Python, we have a function input. So this is how you can take input. Okay, so I'll just comment out this code. I'll press Control and backslash. This is how I comment the code. So when you press Control and backslash on the keyboard, so in VS Code you will comment out the code. You can see that hash symbol appeared on the screen. So now it won't read this. So within the input, I can also give a parameter as string. Okay, let's suppose I'll say, what is your name? This is what I mentioned. And now after that, I'll print that name. So here again, if I just run this file, so running this, so it is giving me now a pop-up. This is called as blocking function. Blocking function means it will block till that I don't enter anything. So here the first line is being executed. Input, what is your name? So it is giving me what is your name. I'll have to input a name. Let's suppose I'll say Mahmood. Okay, but still it is giving me hello Ejaz, because this input I have done nothing with it. Okay, so here I am introducing one more concept to that. So now you have a function. It's like why are these called functions? Because it's taking some input and giving some output. That's what functions do. So they take some input and they give output. That's why I introduced functions. Before programming, I introduced functions. So now I'll have to give an input and I'll have to get an output. And now this output has to be stored somewhere first. We'll have to store it. That's the reason I introduced variables. So now you know that Mahmood, what is your name? I entered Mahmood. It will be stored somewhere. It will be stored in the memory location. Now variables is the form where I can bind these variables. That's called variable binding. I'll bind that variable. I'll store that name into something. So now I'm getting input. Okay, coming back, I'll just erase this. So if you see this, so I'm taking input, what's your name? Now I know that this is a function. This input is basically a function, input function. So I am giving it, what is your name? It will return me something. So when I enter that name, it will return that name to me. I have to store it somewhere. So what I do is I'll store into name. Okay, so this name is now a variable. So this name, if you see, is a variable. So now if you see that I have an access to this, I can just print out this name. So if I print, I'll say print plus name. I'll just print the name. Let's say I'll print the name only. Then we'll see the formatting. So I'll just save the file. I'll go back here, just run the file. It's saying what is your name. Let's suppose now we'll write Musawwir, and then you say it's saying Musawwir because I am printing this line, and then I'm saying hello Ejaz over here because this is getting printed. Now I somehow want to replace this Ejaz by the name. So what I can do is I can just say hello, and then I'll put comma and I'll let name over here. And I'll comment out this code. Now if you see this, if I run this code now, so it's saying what is your name. Let's suppose I'll say my name is say Arshan. If I print it, it is showing me hello Arshan. So is it clear how do we take this input and how do we print the name on the screen? Is it clear so far? So now you saw how do we take this input and how do we print it on the screen. Now you have to store a different type of things. Now you have to store name, you have to store, let's suppose, income, okay, and you have to store your expenses. All of these things have to be stored. Okay, that's where we bring in these Python data types. Now you know that name, it is made up of these letters and probably words, and income is just numbers, okay, and expenses also is numbers. So from this perspective, we'll have to have a different mechanism of storing these different data types, because all these things is basically data. Now we'll have to store the data. Okay, how do we store this? In the machine, there's a different mechanism for each of the things. If you go on to these IEEE 754 standards, they have defined how do we store floating point numbers and how do we store these strings, how do we store these each characters, okay? Because computer at the end understands just binary, it understands just ones and zeros. Now we'll have to have a mapping. In order to store something, we'll have to have a mapping. Now you know that this name is basically made up of letters and made up of words. Income, expenses, they are made up of numbers. Okay, there are the different types of numbers. Some are floating point numbers, integers. Okay, for that purpose, in every language, or if you say if you are developing a programming language, you must define these data types. Okay, now what I'll do is I'll introduce Python data types first, because now we'll have to store the name, we'll have to store income, we'll have to store expenses. Okay, have that in the back of the mind, because now we took the input, we'll have to store it in something. Okay, and the type of the data is different, and for that purpose we must know data types. What are different data types that are supported in Python? So data types in Python, I don't need to define them. I hope that you got the gist. What is the meaning of data type, and why? The question is why? Why can't you just store everything as one thing? Because computer only understands binary. So for each of the thing there is a mapping. Let's suppose you are storing A, B, C, D, something like this. Okay, computer does not understand this A, B, C, D. It only understands ones and zeros. So we assign these things some numbers. Okay, we assign these things some numbers, and these numbers are basically then converted into binary. Okay, and we have different encodings, Unicode, ASCII, and stuff like that. I don't want to you guys to get into those details. Just abstract the details out. We don't have to reinvent the wheel. But I hope that you know that computer only understands binary, and for that purposes, let's suppose if we are dealing with numbers, so numbers are then converted into binary. And if you have this letters, so letters first have to be converted to numbers, and numbers to binary. Okay, and now even if there are different numerals also, let's have integers. For integers, it's easy. So how do we store integers? So we store integers in what's called as 2's complement form. I had no plans to discuss this, but I want you guys to at least have the notion that why do language define different data types? Okay, what is the need of different data types? Because humans don't think this way. Probably what humans do is we just have a type of data and we don't care what is this, and it's a string if it's a name. But here in order to make computers understand, So the basic principle is that you have to write everything in binary. Now you know that you cannot read all the binary. So what you have, we have different levels of abstraction. So the first abstraction is if you are storing numbers, so you'll convert the numbers into binary. So what are different types of numbers now? So what's the need? So I am answering what is the need of different data types. Okay, what is the need? The answer I gave is that the need is that computers only understand binary. Computers only understand binary. So when I was in my undergrad, I thought they probably understand ones and zeros, but computers don't understand ones and zeros also. They just understand electrical pulses. Either the pulse is high or it's low, and if there is a certain voltage being applied, so we say that okay, current is flowing through that. This is one. Okay, but we have just abstracted out by using maths. One basically means current is there. Zero means there is no current, and something like that. Okay, so that's why even this binary word is again an abstraction. So what actually it understands is just electrical pulses. If it is an electronic computer, or if it's a mechanical device, we probably might have some positions. Okay, that's what I discussed, Turing machines and stuff like that. So computers only understand binary. Now we'll have to encode every information in binary. So if we have what types of data we can have? So we can have numeric data type. Okay, we can have these characters or bunch of characters. We call that a string. Okay, so in numeric we also will have, let's suppose, integers. Okay, and then we'll have floating point values, floating point numbers, and in characters we'll have different. These basically are called sequence sets. I'll just give a brief diagram representation of that. But I want you to understand that what is the need of that. The need is computers only understand binary, and we should have a layer of abstraction. So why are we even saying that integers are different, floating point are different? Because that's how computers represent these numbers. There are different standards being made. Okay, integers, we represent them in 2's complement. I think people from electrical background who know these microprocessors, 8085, they have to have these. They develop an instruction set. What are the instructions that are defined on the computers? And okay, the people who have read digital logic design, so there you know that how these numbers are being represented. So integers basically are represented in 2's complement. So now these floating point numbers. Now if you know that we have something defined as precision. Why is the precision defined? Because there are infinite number of floating point numbers. Even between 1 and 0 and 1. There are infinite numbers in between these two, 0 and 1. Now you'll have to, let's suppose you have to store in computer's memory 0.001583, something like this, with infinite precision. This is not possible because we have a limited memory. Okay, so what we do is we somehow have to do rounding of the numbers, and for these we have standards. So that we have IEEE 754 standard. If people want to read these, and you can read it up. But these floating point numbers, they are represented in this standard. So there are a set of rules. How do we define them? Okay, there is some ruling. I'll just mention it over here. So we have a sign bit, then we have something called as Mantissa, then we have something called exponent. Okay, and then there's a formulation of conversion also. This sign bit is either 1 or 0. So 1 means negative number, 0 means a positive number. Then we have this Mantissa. It's again a binary. Okay, so what I was saying is that, so these integers, these discrete values, if you have 1, 2, 3, let's say -1, -2, so we represent them in 2's complement number in the computer's memory. And these floating point numbers, as you saw the problem that we had, the problem we had is that floating point, they are uncountably infinite numbers. So in between 0 and 1, there are uncountably infinite numbers. So now, but we have a finite memory. So we have to somehow do this calculation. We have to somehow store them into the computer's memory. So for that we have developed standards. So there is something called as IEEE 754 standard. It's called, there are two standards. One is called a single precision standard, single precision, and double precision standards. Okay, but understand there are some of these standards. I don't want to get into detail, otherwise they'll take one whole lecture. What are the standards are, and what the problem with that standard? What's the highest number that you can store? That's why there is something called as overflow and underflow. Okay, because computer's memory is limited, so and you have assigned limited bits, you assign limited memory to these representation of the numbers. So if you just keep on adding the numbers, after a while you will find the number got overflowed, and that probably we'll see in the operators. I'll show you what overflow means, what underflow means. That was the first problem in the first code. So in the previous session I somehow told you that the first bug was that. So the code was written in such a way that it was assigned, I think, 16-bit register, but the counter needed 32-bit register, and I think the first error crash was because of that, and probably we'll discuss that thing in more detail. But again, coming back to this, zooming out a bit, so we're discussing data types in Python. I hope that you got the understanding why do we need different data types, because we have to store it in the computers and we have to store it in different format, different way basically. So numbers, how they are stored, they are stored in 2's complement. By numbers I mean integer numbers. If we have minus 1 0, because they're discrete numbers. Again, floating point numbers, they are stored in what's called as single precision IEEE 754 standard, or maybe double precision. So double precision gives double bits. I think it's 64 bits. This is 32 bits, and 1 bit is for the sign. I don't remember the numbers exactly. You can check it. You can check it online for the documentation, and where you will get the exact numbers. But you guys, I hope that you guys got the gist of what is the need of different data types. Now we'll see what are data types that are supported in Python. Okay, so what are different data types that are supported? So I'll write data types. I'll take digressions. Do tell me that sir, you are digressing too much. I'll come back. So what are different data types? So I'll just write, the first thing is numeric. Numeric basically means numbers. Okay, then we have, let's call them sequence types also. So this is but specific for Python, sequence types. Okay, and then we have also Boolean, and we have dictionaries, and I can write one more over here, and we have set. Okay, again, if you see that this set is from maths. Okay, this Boolean is from maths. Now within the numeric, what we have is we have integers. Okay, and then we have floating point numbers, and then we have complex numbers. Because these are the numbers that we deal in mathematics. We deal with either integers or floating, which we call as decimal number, or there's a decimal point, or we deal with complex numbers. Okay, then within this sequence type, so sequence type we have strings, and we have a list. This is again a sequence, and then we have a what's called as a tuple, or some people pronounce as tuple. So I'll pronounce as tuple. So this Boolean is basically either 0 or 1. Okay, and then we have a dictionary. Dictionary we have key and value pairs. Okay, dictionary we have key and value pairs. So these are the data types that are supported by Python. Okay, in numeric we are supported, integers are supported, floating points are supported, and complex numbers are supported. In the dictionary we can define a dictionary which will have key value pairs. So what's the meaning of dictionary? So you have a key corresponding to that, you have a value corresponding to a particular key. Let's suppose we open a dictionary, you want to find the meaning of some word. You have that word and correspond, there is a meaning. So that's what dictionary is. Boolean, some statements are either true or false. So that's why we introduce one more data type, that is true and false. Then sequence basically means where order matters. So if you see in different things, order matters. Let's suppose if I write apple. So here the order of these letters matter. So that's why it comes on sequence types. So Python has given us strings, lists, and tuples. And then we have set. Set means where order doesn't matter. Order doesn't matter, and there are different operations that are defined on the set. So for all these data types, okay, they're basically objects of some class. So we'll see what objects our classes are. But here I want you guys to know that these are the supported data types. Okay, if you want to check the type of data, let me go to the coding window and we can check that. Okay, now we'll go to the interactive environment again, because I have to check these things, so it is better to use the interactive environment. So here I'll just enlarge the screen. So I'll write Python 3. Okay, let's clear this out. So if I define a is equal 10, I told you that Python is a dynamically typed language, and we don't have to define upfront what is the data type. So for a language like C, C++, we have to define it. You might, if people are coming from C background, so there you will have to write int a or maybe float a. So that gives the hint to the compiler and hint to the how to store this data. Okay, but here if you see that we don't write this because it's dynamically typed, but at the runtime, Python's interpreter decides what data type should be given to this. So if you see a is equal 10, so now if I type type of a, so you will see that it shows that class int. It belongs to something integer class. It's the object of integer class. So there are different types of objects. Okay, if I write a is equal 10.1, okay, if I now check the type of a, now you see that this is of class float. Okay, because we have a floating point value over there. Okay, so if I write, let's suppose a is equal to hello. So hello is a string. So if I say type of a, you can see that class string. So each of these object types, they support different operations. That's why we have categorized them under different data types. Is it clear so far? I'll pause here for maybe a couple of seconds so that I can take some questions if you have any. Okay. So now you saw that there are different data types that are available in the Python that I have written over here. So if you see, these are the different data types that are possible. So now what we can do is we can typecast these data types into one another. So that's called as typecasting. So what is the typecasting? Let's suppose you are defining some float value, but you are only interested in integer. Okay, but what you can do is you can typecast it. Let's suppose you have a string of number. 1, 2, 3 is a string. 1, 2, 3. If you put it in the quotes, this is a string. So, but if this basically is a number. If you want to get the number out of that, so you can just typecast these numbers, and there are ways to typecast. Okay, let's go to the coding window and see this, how this typecasting is being done. Okay, I'll just clear this thing up. So if you see, if I write, let's suppose a is equal to 10.5. Now you know that this is float. If I just confirm it, type of a is, clearly you can see class float. But I am only interested in integer value, or I want to typecast it. I want to convert it into integer. So what I can write is, I can just write int a. So this int again is a function. Okay, let's store it in b. So if I print this b now, you can see that the value of the b is 10. It converted into integer. If I want to check the type of b, you can clearly see that it will be class int. Okay, so this is one type of typecasting. So you can convert integer, a floating point into an integer. Okay, you can do the vice versa also. So if you want to convert now b into float, okay, so what we can write is, we can write float b. So this will be now 10.0. It was just 10. Now you can see that it is 10.0. Okay, now if I check the type of b, you can see it's of I haven't stored it though, so I'll have to store probably when I converted float into b. I'll have to store it into b. So now if I check type of b, this is class float. So this is that typecasting. Okay, so you can also convert string. Let's suppose I'll write a string. So strn string. This is this is string of numbers. Okay, now if I want to convert, if I check the type of this, so it clearly is a string, class string. Now if I want to convert this into number, so what will happen is, so I'll have to typecast it. So how to typecast? I'll convert it into int, and then I'll say convert this string into integer. Okay, and then store it somewhere. Let's suppose we'll store it into number. Okay, now if I print this number, you can see this is 1, 2, 3. If I print the type of the number, so this is integer, class int. This is how typecasting is done. But the question is that, can we now, if I wrote a random string, so here I have string 1, 2, 3. If I wrote string abc, okay, now if I want to convert it, as you know that this abc is not an integer, now Python should throw an error. Okay, so if I try to convert this string into the numbers, so I try to int of this string now. Now you know that string holds this abc. And the problem is that invalid literal for int, because this is, I cannot convert it. Python is confused because abc basically is not a number. So it's a string, and when we try to convert it, abc cannot be converted into the integers, or maybe it cannot convert into float. But if you have numbers inside, so we have a mechanism for conversion that Python internally does. Is it clear? And it also makes sense because abc cannot be converted into a number. Okay, moving on. So now you saw that there is a thing called as typecasting. You can typecast these different things. If you're int, you can make it float. If you have float, you can make it, let's suppose, integer. Or if you have a string, which is basically a number inside, okay, and you can convert back that into integer or back that into a float, and vice versa. And all these things are done, and there are methods for that. Okay, and if you want to convert something, and many other times you want to convert. So what is the first application of that? I'll show you over here. So this input method that you see over here, so it actually gives you the output of this input is, okay, it's somewhat a tongue twister. So this is a function. Input is a function. So it takes something as input and gives something as an output. So here I am saying, what is your name? It always outputs a string. Okay, let's suppose I'll give it a number also. Okay, let me run this code. Let me clear this. So if I run this code, so python 3 input output.py. So now if I give it 1, 2, 3 also, so I give 1, 2, 3, but still this will be treated as a string. This one, how I need to confirm it? I'll just print the type of this name. So what I can do is, I can print type of this variable name. Okay, and uncomment this thing. Okay. Now if I go back here, so python input output.py, if I say 1, 2, 3. So from my perspective, this 1, 2, 3 was a number. But if I enter it, you can see it is a class string. I cannot do anything on this. Okay, because I said that for each of this object type, if it's a numerical number, or if it's a string, so there are different operations possible. Okay, and we'll see the operations also. There is a method for that. If I want to see what are the operations that are supported by integers, let's suppose. So how I can do that? So I can say Python 3, going back to the Python 3, I can say dir of integer class. So it will show all the methods that are possible, all the things that you can do. So these are all the methods. I will go into that detail, but I just wanted to show you that for each of this object there are possible methods. So okay, it's somewhat the mathematical language. We are developing a language, and for a particular set of these things now, for particular vocabulary, and we are having particular operations that are supported by that. So in here, if you see this, I have just input a name. What I said is, irrespective to whatever you input, this input function will store the number, will store everything as a string. If you give everything, it will just make it a string. So if you again run this, so I'll say, let's suppose 145. So if you can see, class string. But I wanted this as an income. So what I have to do is, I'll typecast it. That's the thing. That's why typecasting is used. So in Python, this input method only outputs the string. So how to typecast it? I'll just typecast it as int. So I'll say name is equal to int of name. Okay, now if I print it, so I'll save it over here. If I see what is your name, if I say 123, so now you say that it's class int. Now you can perform the operations that are supported by the integers. I suppose there's a question. Let me answer that. So here the question was that if I use an input function, so what it does is the output of the input function basically is a string. So now sometimes I just don't, I want name. Let's suppose here I want a name. This should not be an integer, but what if I want an income? So income is basically a float number. So what I can do, I say what's your income? So now I'll have to convert this income. Okay, if I say income, a float of income, I'll have to convert it like this. Income is equal to input, what's your income? Income will be stored in this float, and then I can just print hello and name. I can also print your income. Your income is income. Okay, I'll save this. So now if I say Python input output, maybe I'll clear this display first. So now what is your name? My name is Musawir. What's my income? Let's suppose my income is 10,000. So now you can clearly see on the visible screen, hello Musawir, your income is 10,000 because it's a float number now, because I have typecasted it. So how many of you understood typecasting? What was the need of typecasting? Is there a question, Muntazir? The goal, if we see, is that we want to develop an application or a finance manager. So what we have to do there is, we saw different aspects of that, and we saw what is the objectives, and for that we are now learning Python. It's not that we are learning Python and we don't have a goal. We have a goal in our mind. Okay, so now getting back to that, and there we saw a concept of typecasting. So in the typecasting, you saw the need of typecasting, because input method that you understood, it only gives a string as an output. So now you have to convert into float. And why do we want that? Because each of these data types, they support different operations. I hope this is clear. And now you can format the input also. You can put this input into a certain way. I also would like you to show the formatting. How do we do formatting? I think typecasting is done. So let's go to the formatting. How you can format. Okay. So let me go to the coding window over here. I hope the screen is visible. Now if I want to format it, let's suppose, so here it shows hello name and hello, there are something called f string. So how I can write it better is, I can just write one print statement. So what I can do is, I can say f and then put these quotes. I'll say hello, name and income. So if you see, I wrote this hello, and then in the braces I wrote name, and your income is this much. So this is how I can format this. So I just wrote this is called as f string. So you wrote an f string. So you said f, then hello, and then put these, this basically is a value holder over here. Name is a value holder. That's how you define this name over here. And then your income, this again is a string. And now you have a holder over here, that's income, and you hold this value over here. Now if I run this, you can see I wrote a cleaner code now. So I can just run this file. You can, what's your name? My name is, let's suppose, Ejaz. Ejaz is a rich guy. Let's suppose he earns a lot of money. So now you see that, hello Ejaz, your income is this much. I just want to delete this type. Okay. Now Mahmood is way richer than Ejaz. So that's the income. So now what I can do is, I can also format in different ways. Okay. So how I can format it? I can, let's suppose I have to print this multiple things. So there is a function format also. So if I say print, so without this f strings even, so if I write hello, there are different ways. So you can see that I wrote this plus name now. Okay, so I say hello, and this is a string, separate string now. Then I am adding this name, because name also is a string. Okay, sorry. It auto switch, I don't know why. So over here, if you see this, this was the first f strings I explained. I hope that till this point coding window was visible. So what I have done is I'll say this is hello, and then here I am putting this placeholder, this value holder basically. So this is the name, and now if you see this income over here, so this is again a placeholder. So this is what's called as f strings. I can just comment it, hash usage of f strings. This is basically under the topic formatting the output. This is how I format the output. Okay, so now if you see this, the first f strings I use, the syntax is that you write an f, and then you write hello, and you said this is a name, okay, and then your income is, and then you are writing the income in these braces, and these are placeholders. Okay, if I just remove this, so you can put something else over here also. Okay, but in order to show these variables, because you are storing some values into these, in order to show them on the screen, you'll have to write them in these curly braces. Okay, now if I comment this line out, I'll again run this code. So just going on this screen, your name is Ejaz, okay, and you can see the hello Ejaz, your income is this much, or this is by using the f strings. So now I can also format in this way. Okay, so what I wrote on second line is that, so if you see this, print hello plus name. So this hello is a string. Okay, string also supports an operation called as concatenation. You can concatenate strings. You know that name is a string. Okay, name is a string. I am keeping it as it is. Then I am saying your income is, because now I know that this income is basically converted into the floating point. I again want it as string. So if I remove this str, what will happen is, because now you cannot concatenate a string and a number, you can just concatenate two strings. So for that, I am converting typecasting again back into the this string, so that I get the income. So if I just again run the code, what is your name? Mahmood, income, something like this. So you can hello Mahmood, your income is this. There are different ways of this, and then there's a format function also. So this is by using string concatenation. So here if you again see, so we can use the method from using format method. Okay, so how you can do this? If you can see here, I have written a code. I said hello, and then here I want the name. I just applied the placeholder, and then I said your income is, again apply the placeholder, and then I said for dot format. This dot format is the method, and I'll just give these two variables which I have, this name and the income. Okay, if I just run this code, again the same thing should pop up. So now let me clear this. Python, your name Mahmood, what is the income? You can see hello Mahmood, your income is this much. So we have seen different types of formatting. Okay, now I'll just switch back to the pad so that I can write things. Okay, so what I said is, so in the formatting we learned typecasting, after that we learned formatting. So in the formatting I said how to format the things. The first thing is you can format it by using f strings. So what I did in f strings, so I just put an f and then put quotes and basically write the string over here, whatever you want to print, and then I am writing a placeholder. So this is called a placeholder. Okay, and then I am writing something else, again a placeholder. Okay, how many placeholders you want, you can write, and in these placeholders whatever data you have collected, let's suppose you collected income, let's suppose you collected or you received from the user its name and stuff like that, you can just put in over here. So this is how we use f strings. And then the second method we saw, we use concatenation. Okay, because we know that on strings the operation is allowed. You can concatenate two strings. If you have a string, let's suppose a is equal hello and b is equal, let's suppose Ejaz. If I write a plus b, this will basically concatenate these two strings. So for that, what I can use also this for formatting. So how do I format that? That I showed on the code. The third thing is there is a format method. There's a format method where you can use that. So these are the ways how you can format, and there are different ways also. You can just align these things. There are documentation available. But I just wanted you to show you that in each language there is formatting mechanism. How you want to format the text, where you want to show it, and how do you want to basically show it to the user who is using your application and things like that. And there are different ways. I hope that these three ways probably will give you access to the majority of the things. I think if you know these three ways, you don't need to look for more. But there are also some advanced ways where you can align the text, and then you can just check for the documentation. I'm just pausing here for 30 seconds to address any questions if you have. So what I'm saying here is when you format the input, let's suppose you collected income from a user. Okay, so he gave you the income, or he or she gave you the income, he or she gave you the name. Okay, and these are the basically values that are here. Income can be, let's suppose, 10,000 or something like that. Name can be Ijaz. Now you want to format it in a certain way. You want to show it in a certain way. So this F strings, what they do is you can just write F and then write everything in a string. Okay, string is basically you can write in plain English. But wherever you want to use these variables, okay, you will just put in curly braces. So you can say hello. You could have write directly name, hello name. But you know now though that this name is a variable, it holds some values. Okay, now you'll put curly braces onto this. So what it'll do is it'll evaluate this expression. So it'll print hello and then it'll go to this name variable. Okay, and then it'll say okay, the name is Ijaz, so it'll print basically Ijaz. So otherwise you can hard code it also. You can just say hello Ijaz. But it is better that you know that these are the things which I take from user. So you take this from user. So for each user, they'll have different values. So it is better not to hard code these values, rather to have this sort of thing where you can dynamically change the name. Okay, if you have this name, so I can just type hello name, but I know that this name is a variable, it holds some values. That's why I'll write in curly braces. Then I can write again the string. I'll just write the plain English again. So your income is. So what I can do is I can write your income is income. So but I know that this income again is a variable, so it stores some value. So I can just put curly brace again. Okay, then I can just close it and I can print it. Not like this, I can print it and I'll do it like this. Is it clear now?
Yes.
Okay.
And you are saying that there is a different method for this.
So I said there are three types of formatting, how we can do formatting. The first thing is what we learned is by using F strings. Just summarizing these things. The second thing is by using this concatenation. The third way is by using a function, that is called a format function. That's a method. Functions, methods, I'll use these name interchangeably. So there is a format function which takes these values. So I showed you all the three ways. Let's again go back to the coding window so that it's clear. I'll just show it in maybe a couple of seconds. Okay, so if in the code window, if you see it over here, so here I'm taking this name, this is a string, I'm taking income, I'm making it a float value. So the first method that I showed you how to format this is by usage of F strings. I'll use F strings. Okay, so I'll use these F strings. So how I use the F strings, I'll just put an F, hello, and this name, I'll just place it in the placeholder. Your income is this income. If I just save it, if I run this, you can clearly see my name is Ijaz, income is this much. So your name is Ijaz and income is this much. This is by using the F strings. So now I can concatenate also. So I can just put these strings together. So if you see hello, then I am adding plus name. So add symbol here, it just concatenates the strings, two strings. So this name is a string, so I'll just concatenate. Plus your name, your income is. But I know that this income is not a string anymore because I have converted it into float. So now in order to get into string, I'll again typecast it. Okay, let's suppose I remove this. If I remove this and if I run this code, you'll see an error. There should be an error. You never can believe in the language. So here you can see the error. Because why? This plus income is basically a float value now. So this float value cannot be concatenated with a string. So this float value cannot be concatenated. So now in order to convert this income into the float value, into the string. So what you can do is it's a float, you can just type str over here. So now if I run this code, it should run perfectly. What is your name? My name is Mahmood. Income is this much. So you can see hello Mahmood, your income is this much. This is the second way how we can show the input to the user, how we can show the output to the user. So we took an input and we showed the output to the user. And now let's suppose we want the third way. Third way is by using the format method. So method is a function, we call it. There's a function format. So we can use that also. So in here, if you see, so I have written hello and then put this placeholder and then your name, again put a placeholder here. So at the end, I'm applying this dot format, if you see. So this dot format is a method. It's a function. So what it does is it will take this name and income as an argument. Okay, so if I now run this, it will again give the same input, same output. So my name is, let's suppose, Mahmood again. I'm using Mahmood's name always. So here if you see, on the screen it showed hello Mahmood, your income is this much. I hope now this is clear. So here we have a question that let's suppose we have a placeholder. This placeholder is there in this placeholder. So if you change the order, so these things will be printed in the same order. So this name will go to the first place. So over here if you see, let me go over here. So if you see over here, so this is the first placeholder. So the first place value will go over here. So name will go over here. So again your income, the second placeholder is over here. So this income will go over here. The order matters here. So if I just reorder them, you can see the code will give you the output accordingly. So I just put the income first. I'll just put this name second. So if I now run the code, so let's suppose I'll run the code. I'll say my name is Ejaz, something. This is the income. So you say hello this, and your income is this. Okay. Now you so clearly saw the difference. Okay. So the order matters here. Nice question.
So, Mr. Sir, I have one question. So, is there any performance difference between three methods?
Yes, there will be. It depends on how they have implemented. If we want to check, we can check it. There will be differences. Yes. Don't lose the fact that we are basically going through a development process. हम लोग कोई चीज develop कर रहे हैं. But for that, what we have to do is we have to learn all this detail. That's why I showed you how to take input. Now you'll have to present this this output, whatever you input, whatever input you took, and you have to present it in a formatting way. That's why we learn different types of formatting. We learn typecasting also, how to typecast these things, and you saw the need of typecasting also. I hope that all in all the picture is getting clearer. So what is my intention behind that? Why am I? Because we are developing a project. So I hope that everything is clear so far, which I have taught you. So let's move on now. Now we'll see what are the different operations that are being that are there. Okay, we'll see operations now. In the input also we'll come back to these functions, because input we have a lot of things that we can do with input. We have to split input sometimes. We have to again align these things. We'll see precision and all of this stuff. But here what I want to do is now we want to operate on these things. So we should have operations. Okay, so operations that are supported. Operations in Python. What I said is that I said for each data type, the data that we have, it can be a string, it can be an integer, it can be a complex number, it can be a set, dictionary, whatever you have. So there are certain operations that are allowed on these things. Okay, so I can categorize these operations under different types of operations. So what are the operations that are supported? Let's suppose we have a number 12 and we have number 13. So you know that we can add these numbers, we can multiply these numbers, and these are things operations we can do. And let's suppose we have booleans. Okay, we have boolean values. So on boolean values true and false, we can have an AND operation, we can have an OR operation, we can have a NOT operation. Okay, we can have an XOR operation. Okay, on all of these data types there are different operations that are possible. So what are the operations that are supported by the Python? Okay, every language has this. It's not specific to the Python only, but all the language they support different operations. Okay, so the first operation type that we'll see is arithmetic operations. Arithmetic operations. Okay, so operations in Python, they basically are symbols again, and they are sometimes special keywords. So they are used to perform these operations on these variables or the values. Okay, and we'll perform these operations onto these values or the variables. Now we'll see what are the arithmetic operators that is support. So the first thing is, you know that they'll be applied on numbers. So they'll be applied on numbers. And the other operators sometimes they're overloaded operators. Okay, we'll see what overloading basically means. The first operator that we'll see is addition. So you know that it will be addition. So addition is defined by this symbol. So again subtraction, this is defined by this symbol. Then division by this slash, and then we have multiplication, that's defined by this. And then we have what's called as floor division. Floor division, we'll also see that this is some double slash. And what else? And there is one more, exponentiation. Python supports a lot of operations. Exponentiation, so that is with double star. Okay, and then we have modulus operation also, modulus. So that is by this percentile symbol. So we'll see each of the operation in a bit of detail so that you guys understand it. So addition, I hope that you guys know what addition means. So addition basically means you just add two numbers, or you'll have something, let's suppose 12 and you will have 5, and you want to add these two things up, so you can just put this addition operation plus. This is just, these are symbols. So these are the symbols. Again, the question is what is internally happening. So internally, I said you that each of this basically what it does is it will call something internally. So what it does is, so this addition calls a function internally, that's called as these are called as Dundle methods. Okay, that's in syntax sugar. I won't go into that. So it calls this underscore double add function. Okay, so we'll see that also. Let's go to the coding window to show you that. I hope that you saw these operations. So these are arithmetic operations that are supported. So let's first start with addition. Okay, now I have this income with me. Okay, just wait a second. I'll just switch the screens. So now I have this income with me. Okay, this is income number 1. So I have source 1 income source 1. What is your income from source 1? Let's suppose from source 1. Okay, and accordingly, what is your income? Income 2. What is your source? Income from source 2. Now I want to add this income, total income. So if I want to add this number, so what I can do is I'll say income, I'll say total income. Let's just convert these numbers into integer now. So how to convert? So I know this is string. I can just put int int and I can convert whole of this thing together. Okay, and then same thing over here. So I can write int int and put the whole thing. Now I know that these are integers, and probably I should have done it floats, but it's all right. Okay, let's suppose we have an integer value of this income. Now I want to just add these two things up. Okay, so how to do that? Total income. Sorry. So this should be total income, that is income 1 plus income 2. Okay, so income 1 plus income 2 will be stored in income. Now you know that this will be a integer value. So now you saw that this addition is used over here. So now if I press Control S and if I run this code, so what is your name? Name is Ijaz. Okay, what's the source one income? Let's suppose I am earning 1,000 and I am earning 20,000. Total income is 21,000. Okay, now I am adding these. So this is what operations, and this is income 1 plus income 2. This is the symbol. So what I said is, I said internally what is happening. So internally what is this plus doing? This plus is basically calling a function. It's called internally calling a function. So which I can see. So I will call that function probably dot add. So if I write it like this, so it will also perform addition. This is just the what's called as syntactic sugar. So if I do this, actually there is no symbol basically. Internally symbol is not there. But for the ease of programmers, that's why plus we define. Actually it calls this function internally.add. If I do the same thing, you can just check. If I just run this code, again it will do the same thing that has been done earlier. Ijaz, source one income is 1,000, 20,000. And you can see, hello Ijaz, your income is 20,000. How many of you got the clarity that that is just a syntactic sugar? That is just a pun there. That actually plus addition is basically given a symbol and that internally calls this function, this add. Is it clear? So how I know these things? Because you have to read optional documentation. What is happening in the plus and how is this addition even? This addition is a method. So how is this implemented? We'll see that in the detail. But here I want you to know that it's not necessary that you write symbols. So it is for the ease of programmers. You are writing that income 1 plus income 2, that gives you income 3. Okay, but this is what internally happens. So this is first argument dot addition and then income 2. So I'll again go back, not showing this. Okay, any questions? I'll just pause the recording. So we're learning about the operations. The first operator that we saw is arithmetic operators. So in that we saw addition. So I said internally what happens. So there are these magic methods called. So magic method for the addition is this add. Okay. So the anything that you basically do is when you perform this plus, so it internally calls this method addition. Similar with the subtraction and division also. So what this division does is it always gives you, so these addition and subtraction. If you add two numbers, there is something involved. I want to discuss about that. Okay. So when you add numbers, let's suppose you have an integer number. A is an integer 10. So B is also an integer, let's say 120. So if you add these two numbers, you'll say A plus B. So now you know that it will be 130. So 130, let's suppose it will store it into C. So C is 130. So now type of this will be an integer. Okay, so this will be of type integer. Okay, let's go to the coding window to confirm this. If what I was speaking is right. So now let's move to the coding window and show you that. And I'll show you in the interactive environment. Okay, let's just clean this code. So I'm saying I'm going to Python 3. Let's suppose I define operation A, that is 10. Okay, I'm saying B is equal to say 20. Now what I can say is I can say type of A plus B. So addition does not change their type. So it will be again integer. So A is an integer, B is an integer. So when you see the type, it's again an integer. But if one of them is float, so whole the expression is a float now. So let's suppose A is equal to 10.0 now. Okay, this is a float value now. So I can check it. Type of A. Type of A, if you see over here. Type of A, if I print. So this over here is class float. Now if I see type of A plus B, you can see it's again float. That's the thing to learn. So what I said is, so if you have two integers, if you add them together, the resulting value is also an integer. But if one of them is float, okay, when you add the numbers, it'll be converted to float, and because it makes sense. But if you convert it into integers, it will lose some values because it will truncate it down. Let's suppose if I have an integer, if I have a float value, A is equal 10.5, let's suppose. Now if I print A, you see that A is 10.5. If I check the type of A, it should be float, so you can clearly see this float. Now if I convert it into an integer, so if I say int of A, so I am converting into an integer. Now if you see, it will truncate down the values. It will say only 10. Okay, this is called as truncation. So 10.5 was truncated down, so it was just removed out. So you just got 10. So that's why when you add two integers, so it makes sense to give an output as an integer because we don't need floating point. But when you add two floats, it'll give you a float. If you only one number is a float, it'll again give you a float. Okay, so that is one necessary thing you must know. Because why do you need these details? Because when you are coding, sometimes you see the value I expected is not what value I am getting. So probably you have to define, you have to be careful, how should I define it float or should I define it in integers. Is it clear? Just clearing out this. So this is what I showed you. So if you have two integers, and you will get integer over here. So integer plus integer, the type again is integer. So but if you have one float and another integer, or maybe both of them are floats, float plus float, so you will get, in these two cases, the output will be float. You have to be careful with these details. Why am I saying you this? Because I know the pain of these things. So once you go to this, and if you have defined a number as, let's suppose, integer, okay, and you lose these things. Let's suppose I showed you, if I have 10.5, if I have this 10.5, okay, so if I convert it into int, you will just get 10 as an output, and sometimes you'll bang your head on the wall. What is happening? Why am I not getting the correct answer? So you'll have to be very careful while defining these numbers. Sometimes it's better to define something as 10.0 because 10 is an integer, but once you add something onto it, if somehow it gets typecast into integer, you lose different information and you will get different answers. That's why I call it simple semantic errors. The code is running perfectly, but you are getting the wrong answer. So you should be careful about all these details. Okay, now moving on. So with the subtraction also same thing happens. So okay, the same thing happens with the subtraction. If you want to subtract two numbers, it will have the subtraction, and the same thing will be done. Okay, so now let's move on to the different operators that I have written over here. So I think subtraction, multiplication is again division. So you should not divide by 0. Okay, there you should be careful. Okay, divided by 0, and modulus operator is, it will be just give the reminder. Okay, let's introduce modulus operator also. Okay, so you know now addition, you know subtraction, and you know this multiplication because they're quite easy. So here for the division, it always gives a float number. So this depends. If you are having two integers, so it will give an integer. If one is float, then again. So all of these are basically binary operators. So what I mean by binary is they take two operands. Okay, binary operators. It's a mathematical detail that you must know. And some things are ternary operators. They take 3 input. So this addition takes 2 inputs. So here there should be a number, and here there should be a number. So that's why it's called binary operator. Okay, there are ternary operators also. Okay, and we'll see that if else is a ternary operator. So that's also an operator. So there we'll see what ternary operator is. Now coming to this, I think division also. So this is not float. So this is division. It gives you the float. So we have addition, subtraction, division, multiplication, and let's suppose what is the float division. So this is one additional float division. So this is one additional operation that is not supported by the language like C or C++. Probably C++ might have that, but C originally does not have that. So what is this float division? Let's suppose you have a number A is equal to 10 and you have a number B is equal to 3. Okay, so once you divide it, once you do A divided by B, so what you will get is you will get 10 divided by 3. That is 3.3333. So now what you want is you want to truncate it down. You only are you just want this number. Okay, you want float, you want to close this number. So what you get is you just got 3 over here. Okay, so you'll truncate down this detail. That's what float division does. So it will just give you answer as 3. So if you have 100 divided by, let's suppose some 9, so you now know that it will be some 11, it will be some 11 point something or like that. It will just give 11 as an answer. So let's show you that in the code so that it's clear to everybody. Now we'll do this on the income also. Code is visible, I hope. We'll do it in the intact environment. Let's suppose I'll define A is equal to 10. I'll define B is equal to 3. Okay, if I now do A float division by B, this is called as float division. Okay, so if I now run it, you can see that it got 3. Why is it called floor division? So let me go that there are two operations. One is called as floor and one is called as seal. What floor does this? Okay, it's like I think clear from this. So if you have a number 3.33, so now either it can go up, it can go to 4, or it can go down, it can come to 3, because it has two numbers, bounding numbers. If you just go to the go upwards and you see the nearest integer, that's 4. If you see on the lower side, that is 3. On the upper side is 4, on the lower side is 3. So on the top it is ceiling, on the bottom it is floor. So we are getting this floor division. That's called floor. There's operation floor. It's written something like this. In mathematics, we write this. If you write 3.33, floor of this. So this is how it is written. So you write it as 3. So if you write seal is something written like this. 3.33, that will be 4. There are functions also, ceal, and these are functions. So probably I think they are allowed in Python. Let me check if they are allowed. So let's suppose I'll write a ceal. If it does not give me an error, CIEL, probably spelling is no. I will have to check. I think floor is there if I am correct. Let's suppose 4.2. If it's not there, it's all right. But we'll have to import maths probably. Import math.floor. Let's suppose 4.5. Yes. So that the library maths. So where all these functions are defined. So now I can write math.ceal. Okay, I can write 4.6. Ceal basically means upper value. You can see 5. Is it clear? Just showing you the definition of what a floor is, what a ceal is. So ceal is an operation again, and floor is an operation. So here we call it a sealed floor division. So floor division basically means whatever number you give, it'll after dividing the number, it'll take the ceal operation onto that. Is it clear? So in this floor division, what I showed you, it basically is a division. So once you apply the division, on top of that, you apply one more thing. You do a floor. Okay, this is first it will do normal division, then it will apply floor onto that. Okay, and this operation is probably better. Why? If you sometimes are just worrying about the nearest number, floor number, so it is better to use floor because its performance is better than if you just perform the division first, then typecast into integer. So it's better to use the floor. Okay, so there are performance benefits for that also. Okay, now there are exponentiation. So exponentiation is also there. So basically, you are raising something to the power. So if you have 10 and you want 10 raised to power 2, you can just say 10 multiplied 2. That this is called as exponentiation. Okay, so here you can exponentiation. So I'll just show it again in the interactive environment. Okay, so let me go back, clear this window. So let's suppose a is equal 10, b is equal 3. So I want a to the power b. So a to the power b. You can clearly say 1000, 10 to the power 3. Okay. So again, if I can just like that numbers. I don't need to have variables first and then define numbers. So I can directly do the numbers. So like 10 multiplied by, let's suppose 4. This is exponentiation. Okay. Similarly, 5.
So again, it went auto mode.
Is the screen visible now?
Yes. Now it's
Yeah, it does sometimes, and I'll have to fix it. But thanks for pointing this out. So I'm showing you the exponentiation operation over here. So these are the additional things that Python gives you in how do you do the exponentiation? Is this, and I think C or C++, but they don't directly support this. You have to implement these functions on your own. Now you see the design philosophy again. The philosophy is here to ease the programming. So you should have very like high ease in the programming. When you are programming, if you have this, let's suppose you have to exponentiate, you have to keep on multiplying. You can write your own function also, multiply it these many times. But it's better if you have an operation defined over there. So I think we have more or less covered all the arithmetic operation. I'll just cover last one, that is modulus. Okay, modulus operator. Okay, let's now cover this modulus operator. So what is it doing? So it will give the remainder basically. Let's suppose if you have a number 10 and you take a modulus of 3, it will say the remainder. What is the remainder left? So remainder here will be 1 because 3's are 9 and then 1 is left. So it will give 1 as an output. So if you have, let's suppose 100 and then you multiply, take a remainder of the 9. So you know that 9 multiplied by 10 is 9 multiplied 11 is 99. Again the remainder will be 1 over here. So why is this important, this operation? If you guys come from a background of cryptography, you know that number theory is heavily used and this modulus operator is heavily used there. Okay, it's better that we have these operators that are sort of support in Python itself. Okay, just a demonstration for this. So let's go to the window, coding window, and we'll see it. So if I have a number, let's suppose 100, and I'll take this modulus percentile operator, and then I'll say modulus by 9. So you'll see modulus is 1. The remainder left is 1. If I have some number like this, okay, and then probably if I take a remainder 21, so you will see this is what is the remainder is left. I hope that this modulus operator is clear. So we are done with the arithmetic operators. So there are a lot of details that we can cover, but I hope that you guys can check the documentation on your own. So after that, you will get to know a lot of details about these operations. So I'll stop the recording over here. So if you have any questions, I am willing to take those.